Hello everybody, back to renewable and sustainable energy. This is module number 3 and week number 9. We will talk about hydro energy and energy in water. So hydropower principle and hydro energy, and I will talk about the principles of this power, the resources, technology, and then I will move to hydro, where I will talk about tide, wave and ocean. Now simply hydro energy, it's a nature phenomena happened in the nature, where we can see that the water, you know that our planet covered by more than 70% water and land. So when water gets heated by the solar radiation, it gets evaporated and it go up to the sky, it become clouds, and then it fell down as a rain or precipitation, or let me say snow. And then similar to this one, as you can see here, you see here, this is the ocean, is evaporated, clouds, is go here, precipitation or rain, and then back to this is the cycle. So if we can save water in a reservoir, as example, we have a lake or a reservoir, and there is a dam, we make a dam to similar to this one, as you can see here, the water here, okay, then the pressure of this water can rotate turbine, as you can see here. This turbine connect to the generator, generate electricity. So the mechanical energy coming from the pressure of the water, of the head water, okay, the water will flow here, rotate this turbine, and then go out. Definitely the dam and reservoir here, we are saving the water to have a policy for the, or let me say plan for water used in irrigation. Okay, we want to organize our water usage, but at the same time we can generate electricity. It's one of the best type of or method used to generate electricity worldwide. Now here, as you can see here, this is simple from the old days, simple turbo generator. As you can see here, this is water wheel. Okay, water will flow here, rotate it, connect to shaft, gearbox, and then generator generate electricity and take it to the load. Okay, this data from EIA, International Energy Agency, 2001. It's all data, 20 years back. Okay, but it gives you indication about the hydro contribution in generating electricity. Now we know that natural gas, coal, nuclear, blah 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 are using, but hydro is taking part of share of the cake. Okay, in the past, it's only before it start used for generating electricity, it was used for grinding for wheat or corn. As you can see here, when we have let me say corn, okay, we put it here to grind it. We need mechanical energy. Water will rotate this wheel, so we got the mechanical, or in this way you can see water will fill here and it will make a pressure, it will rotate, and then it let me say move the water in this way with the water, okay, this way, the shift here for grinding. And the same thing here, you see here corn, okay, this is the wheel rotating by the water. And another example, these all days, let me say, applications. Now there is a projection and expectation that 2050, you see, this is renewable energy sources, this is non-renewable energy. So they expected that around 50% of electricity generated globally will be by renewable energy. Hydro is taking interesting shares, let me say. Now if I talk about advantage and disadvantage, the disadvantage could be, one of the disadvantages could be it's not always raining and water not always, sometimes the weather is dry and we don't have enough water for the reservoir, or the places where some countries they don't have water at all. I mean, or let me say, they have difficulty in getting water, so they cannot use this technology. Okay, or the construction of the dam itself, it's costly and take long time, few years, okay, to construct it. Also it changed the location totally and forever, okay. the life change there. If there is village, the villagers life will change. If there is livelihood, it will change. Everything will be changed there when we build our our hydro power plant. Now the good issue is there is no direct waste, no waste, okay, no ash, no CO2. I mean, or the level of CO2 comparing with fossil fuels is almost nothing, okay, and the installed capacity, which is 777, really interesting number, gigawatt electricity, tell me that it's huge. It's not small. This is 2006 old, okay, data, but it tell me that it is a huge amount of energy used. In some countries it may reach 20 to 30 to 40%, depend on the water available in the country. Now here, this data talking about 2005 up to 2005, okay, and this is the annual output in terawatt hour coming from hydro. See the increase. This means that there is investment in this. Many countries invested in hydro. They have water, so they use it. Example of them, these are talking about the producers, the installed capacity, the countries. But let's have a look at this table, the first one. Canada, Brazil, United States, Russia, Norway, Japan, many countries. How much they produce in terawatt? Oh, 338, 306, so it's a huge amount. How much they present percentage of the world producers? 12, 11. So these countries, they depend on hydro. They use hydro. They invest in hydro. Okay? So it's really interesting energy and large. As you can see here, it's not, this dam, this is the lake. And this dam, these are the valves to open for the water. Water will flow, rotate, turbo generator, generate electricity. Okay? So you see this location for the dam. It's take a long time to be constructed. It's much money invested here, because this one will definitely it will recover. This one will stay for a long period of time, and they need to make sure that it will handle the pressure, continuous pressure of the water. See this one from close photo, or this one. They change the land. They change everything here, and it will continue for a long time. Now, some terminology need to be mentioned here, and then I will go for some example to do calculation. Head of water is the height between the low level of water and the head of the top water. Okay, it means the water falling from the head from here to here. This is H. Okay, it's called head, and this head specify the type of dam. It could be greater than 800 feet. This is called high head. Between 100 to 800, it will be medium head. Lower than 100, it will be low head. And the power generated proportional to the head and the flow of water. Now, the scale of hydropower projects, it could be in the range of more than 100 megawatt. We call it large. Between 15 to 100 megawatt, we call it medium. Between 1 to 15, we call it small. Between 100 kilowatt to 1 mega, we call it mini. Between 5 kilo to 100 kilo, micro. Pico is lower than 5 kilo. This is for house, while 100K for villages or isolated. They're the same thing, the mini. So these are the three targeted in many villages or rural area. I mean, isolated area. They can use these small systems. Different type of turbine available. I mentioned for low head, as example this one. I will talk about it in the next few slides. Medium head, you see here, a little bit higher, and the water will take a long bath. While high head, it's really long bath until you get to the turbine. How it look like the place? Do you remember when we talk about the place for the wind turbine? Also here, some similarity are available, different shape. You see, and they optimize them. It gives different output. Efficiency expected to be high, 75 to 95. You remember solar less than 10 for amorphous, between 10 to or 15 to 20 for polycrystalline, monocrystalline, while wind from 24 to 25, sorry, to 45